Today we'll be going through the steps of transcription. So right here we have our legend for our DNA and mRNA strands. I have a DNA strand right here on the floor. We can tell that it's DNA because it's double-stranded and we have thymine in red. We do have 3' over here, 5' over here, and we have 5' at this end and 3' at this end. Okay, so the first step of transcription is initiation, and what happens in initiation is that our RNA polymerase is going to bind to a promoter region which is heavy in adenines and thymines. This happens because the double hydrogen bonds between adenine and thymine are much easier to break than the triple hydrogen bonds between guanine and cytosine. So now RNA polymerase is going to break these bonds and unwind our DNA strand. Just like that. And now what RNA polymerase is going to do, right after the promoter region, is going to start bringing in complementary nucleotides to our template strand right up top here. And this is step 2 of transcription, which is elongation. So here come our complementary nucleotides, and this is our new mRNA strand. And you'll notice that this is only single-stranded and it contains uracil binding to our complementary adenines instead of thymine. So next is termination, where our mRNA strand is going to disassociate from our DNA strand, and RNA polymerase is also going to disassociate so that it can continue doing the same for other genes, and our DNA is going to join back together, forming its hydrogen bonds again. So right here we have our mRNA strand. This isn't the end because this is currently pre-mRNA and it has to go through some post-transcription modifications. This includes things such as 7-methylguanosine. This is here to be recognized by our translation machinery in the next step. And we also have our poly-A tail right over here so that our mRNA strand will be safe when traveling to the ribosome for translation. The third step to this is that the third modification is that we would have our spliceosome made of SNRPs and different proteins. It would take out the non-coding regions, which are known as introns. So let's say this guanosine right here is a non-coding region. It would just be taken out just like that. And let's also say that these two at the end are non-coding regions. So these two would also be taken out. Would still be here. And right now we have our mature mRNA, and that's the end of transcription. What will happen next is that this mRNA strand will travel to the ribosomes for translation.